Okay, this is the P3 paper from June 2022. It's question number 3. As we can see, this is an integration question. So with our integration questions, pretty much the first thing that we check is, do we have either of these two scenarios, either f-x over fx, or we can sometimes have f-x times some function of fx here. This g fx tends to be fx to the power of n, or whatever it is with that one. Anyway, I'm not too worried about this one because in this instance I've got this scenario here, because the differential of 3x squared is going to give me 6x, and as long as it's a multiple of 6x, 9x is a multiple of 6x, then I know we're going to be looking at this left-hand one. So if that's true for part A, then what we do as soon as we realize it's one of these reverse chain rules is we attempt our basic what the answer must be. So we guess an answer in effect. So I'm going to say I know that the integral of f-x over fx would be equal to log fx. So let's try log 3x squared plus k as my attempt, and then you differentiate it. We differentiate and see just how far out we are with it. We know it's going to be some sort of multiple out. So if I differentiate log 3x squared plus k, that's 1 over 3x squared plus k multiplied by the differential of what's in here, which is multiplied by 6x. So what that means is that 6x over 3x squared plus k, if that's the answer there, then what I've determined is that the integral of 6x over 3x squared plus k would work out to be log 3x squared plus k. Well, I haven't got 6x, I've got 9x, so I've got 3 over 2 lots of that, 1.5 lots of that is going to be what I've got. So the integral of 9x over 3x squared plus k dx, then this is 3 over 2 times bigger than that. So we'll have 3 over 2 log 3x squared plus k. That's my answer. Don't forget to put your constant of integration on as well. Only 2 marks for that, so we don't need to do too much more in terms of method for that. And then on to part B. Part B is slightly different in that it, rather than just evaluate something, yeah, we're going to evaluate it, but our missing variable is going to be k there. So I'm going to put 5 and 2 in, sort out the answers for those bits, and then need to rearrange it to get what k is. That'll hopefully make more sense when we actually do it. So B, the integral between 5 and 2 of 9x over 3x squared plus k dx then. So we know that's 3 over 2 log 3x squared plus k. We don't need the constant of integration now because we're going to evaluate it between 5 and 2. So if I stick 5 in, I'm going to get 3 over 2 log 5 squared is 25. 3 lots of 25 is 75. So it's going to be 75 plus k, that's putting the 5 in, minus 3 over 2 log, and if we put 2 in, 2 squared is 4, 4 times 3 is 12, so 12 plus k. And we now know that all of that works out to be equal to log 8. So what I've now got to do is to just tidy that up. If we take the 3 over 2 out as a factor, first of all, we get log 75 plus k minus log 12 plus k. I'm doing this relatively slowly here. You might have done it slightly quicker than this when you're doing it. But what I can see then is that in there I've got log a minus log b, and I know that's log a over b, so I'm going to use that. So I'm just doing it step by step. You might do it slightly quicker than me, there's no problem with that. So I'm going to say that's 3 over 2 log 75 plus k over 12 plus k equals log 8, and then I'm going to use the power rule. That can just go back up there, can't it? So I'm going to get that 75 plus k over 12 plus k all to the power of 3 over 2. We'll leave the logs in for one last step. But the whole point about doing that was so I can get log of something is equal to log of something. Then I can just get 75 plus k over 12 plus k all to the 3 over 2 is equal to 8. If we do 2/3 of both, I mean power of 2/3 of both sides, then what we're going to do is we'll get 75 plus k, 12 plus k is equal to 8 to the 2/3, and 8 to the 2/3 is 4. Stick into the calculator. Just works out to be equal to that. Right, pretty simple to finish this off then. So 75 plus k is equal to 48 plus 4k, multiplying that out. Get all the k's onto one side and all the numbers onto the other. 27 is equal to 3k there, so k works out to be equal to 9. Let's just go back and check. Yeah, no limits to what k can be there. So, sorry, except the k is a positive constant, but that works out to be a positive constant. So we are sorted with that one. Hopefully that all makes sense.